Here's problem 23.4. A charge of 80 microcoulombs is placed on the x-axis at x equals 0. A second charge of minus 50 microcoulombs is placed on the x-axis at x equals 50 centimeters. What is the magnitude of the electrostatic force on a third charge of 4 microcoulombs placed on the x-axis at x equals 30 centimeters? Let's draw what this is. We have a first charge, Q1, located at x equals 0, and that charge is 80 microcoulombs. And then we have a second charge, let's call it Q2, located at x equals 50 centimeters, and that's equal to a negative 50 microcoulombs. So let's actually change the color on that. It's a negative charge. And then we have a third charge, Q3, located at x equals 0.3, and that's equal to 4 microcoulombs. So that's a positive charge, and that first one's a positive charge. Alright, so we want to use the principle of superposition to find the net force on this third charge. This is 0.3 here, another 0.2 here. Okay, from the two positive charges, there's going to be a force going away as they repulse. That's called F1 going this way. And then from the positive and negative charge, there's going to be another force, attractive, going towards it like that. Let's call it F2. So these two forces are actually going to add together in the positive x direction. Let's find F1. That's going to be equal to K Q1 Q3, or the distance between them squared. 9 times 10 to the 9. Q1 is 80 microcoulombs. Q3 is 4 microcoulombs. And the distance between them is 30 centimeters or 0.3 meters squared. So this is going to be equal to 9 times 8 times 4 times 10 to the 9. And then we'll have 10 to the minus 5 times 10 to the minus 6, which would be 10 to the minus 11, over 9 times 10 to the minus 2. Our 9's cancel out. 10 to the 9 times 10 to the minus 11 is 10 to the minus 2. That over 10 to the minus 2 will cancel out. And this is going to be 8 times 4, or 32 newtons. Going off in the right direction, to the right. Okay, so force 2 is going to be equal to KQ3 times Q2 over the distance between them squared, and that's going to be 9 times 10 to the 9 times 4 microcoulombs and times 50 microcoulombs. Over the distance between them, which is 20 centimeters or 0.2 meters squared. So that is going to be equal to 9 times 4 times 5, 10 to the 9, times 10 to the minus 6 times 10 to the minus 5, which would be 10 to the minus 11, over 4 times 10 to the minus 2, and 4's cancel out. 10 to the minus 2 over 10 to the minus 2 cancels out, so it's 9 times 5, or 45 newtons. And that is in the positive x direction as well. So our net force is going to be the addition of these two on little q, or Q3. So that's going to be, our net force will be F1 plus F2. That's going to be 32 plus 45. or 77 newtons in the right direction, to the right, or 77I if you're thinking in terms of vectors. But the magnitude of this force would be 77 newtons in the positive x direction. That's our answer.